Hey, how you getting on? So recently on a project, I needed to have this sort of a tunnel shape with a camera following a curve and going through it. I know, there's the setup here with constraints where you can just put a constraint on the camera itself. But I wondered if maybe I could use the normals of the curve and extract the Euler rotations that way. So here's the code that does that. And I'm just applying it here to this transform node first of all, because I needed a torus to be moving down the curve as well. Pretty simple, but hey, you might learn something. So here we go. So here's my curve here anyway. All it is just a line, putting a ramp on there by dividing pt num by num pt, yada yada, and then a bit of noise driven by that ramp, turbo noise, vector to float, all this good stuff. And then I'm converting that into an Carve curve, then back to a polygon, and then resampling here. This isn't necessary, but it's just something I wanted to have control over. So all you have to do first of all is pop down a polyframe, get rid of the normal name, change this to the normal, and then we put down a carve, which is carving up our curve. Then we set that to extract, and it gives us a single point. Cool. So if we look at our geometry spreadsheet, we already have our position data on there. So we just need to get the Euler angles. So the way we do this is we pop down a point wrangle, like so. So first of all, we're going to create a vector, n. We'll set that to equal normalize n. And then we'll create another vector up and set 0, 1, 0. And then all we need to do is create a matrix, call it M, and say make transform n and up. So matrices in Houdini are really handy because they can store all the information that we need. They can store position, rotation, scale, shearing. They're really great. If you want, I can explain it in another video, but I want to keep this one quick. But for now, what we need to do is vector Euler, and we're going to use a function called crack transform. And a crack transform lets us extract the data that we want from the matrix. So the way we write it is we first put down 0, 0, 1, and then brackets 0, 0, 0, and then put in our matrix M. So what this is saying here is that, and I must go back to the documentation for this because it's awkward. Okay, so the first entry is basically translate, rotate, and scale. So you can put in like a number between 1 and 6, and we'll pick different orientations of that. Same with X, Y, Z, that's rotation orders, whatever, we don't care. But this one here, C, is important to us because if you see here, the value of C returns to translate if it's 0, rotate if it's 1 or 4, scale if it's 2, and shear if it's 3. And then for 4, it's radians, but we want it in degrees, so we set it to 1. The next one is the pivot, who cares? And the last one is our matrix that we just created. And just so we can see this working, I'm going to put in a fit function here. Fit at frame 0 to 100, 0, 1. Super handy expression, I use them all the time. So now we have our point, moving down our curve over 200 frames. Let's get rid of that resample, it's a bit jittery. There we go, nice and smooth. So what I'm going to do now is I'm going to create a pig head just for testing. Then I'm going to try on a transform. Connect that up there. Here he is. Then we're going to drop down a null. We're going to call this fall out. Then we're going to channel reference this null into our translate here. Then we're going to say point, quotation marks, dot slash, and then there's fall out is there. Then we're going to put in our point number, which is 0. Then we need to put in our attribute, which is P. And then this last number refers to the axis that we're working on, which in this case is X, which is 0. If we look at this now and press play, you'll see that our pig head is moving back and forth on the X axis. So all we need to do is copy this, bam, bam, set you to 2, set you to 1, and there we go. Our pig is following our curve. And then we can do the exact same with our E value. So just copy this over, change this to E, tab and then paste, U to 1, tab and paste, U to 2. And there we have our pig following a curve. It's facing the wrong way. You can just put in a negative here. There we go. Cool. So I'm just going to put this in here just to tidy it up. Just call this for camera. And then now on our top layer, create another camera. And I'm just going to copy, paste relative references, and do the same for our rotation. And now we have our camera following the curve. If you want to visualize this as well, you can throw on a sweep, go onto your curve and set this to round tube. And there we go. And it seems that we're going backwards now too. Whoopsie. Maybe I need to flip this around. So there you go. Nice. And you can use that then to make something cool like this. So thanks for watching anyway. I hope you enjoyed it and maybe learned something. I like making these little quick tips because my memory is like a sieve these days, so it helps me to have this stuff online. But hey, if you can benefit from it too, then we're all good. So go on there now, mind yourself and have a good one, lads, right? Bye!